Good morning. 20 years ago, Linus Torvalds invented Git, and AWS introduced fractional compute, the combination of which created a tool of innovation that was accessible to any developer who could code. Over the next 20 years, 100 million developers created $15 trillion of economic value. The power of Agentic AI is that it's also a tool of innovation, making creativity accessible to any human who can reason. What will happen when 1 billion men, women, and children are able to create new experiences, automate tasks, and create systems that adapt to their environment? How much economic value will that create? My name is Tyler Jewell. I'm CEO of Akka, and we make a platform that makes it possible for you to design, build, and operate agentic AI systems that are fully autonomous, continuously improve, and meet the most stringent SLAs. Our technology has been deployed over 100,000 times, and on any given day, 2 billion people experience an application that is built on Akka. And today, I'd like to share our journey with agentic AI by sharing a couple of use cases. And it has been a journey. It has not been a smooth ride. It has actually been an incredibly bumpy one. Gartner tells us that over half of all AI projects fail to make it from POC to production. A lot of projects get stalled in the experimentation phase, and there are massive concerns around how these systems become reliable and scalable. Well, there is a formula that you can apply that helps you overcome these issues and have a more predictable path into production. And our message is that agentic AI is almost entirely about the engineering and a little bit about the AI. When you are approaching an agentic system, it is a distributed systems engineering problem where your job is to create layers of certainty while embracing the fact that you have these unreliable LLMs that are random, high variance, and stochastic outputs. So how do you go about approaching making AI successful? Well, the first thing is get the engineering right on day one, establish the plumbing, and the AI will work itself out. Incorporate trust, guardians, and evaluation from the beginning, and you'll have confidence that the system is going to behave in a deterministic way. Don't break your architecture or establish something entirely new. Evolve your existing IT systems into an agentic AI system, and then create multiple layers of certainty to further provide confidence and establish determinism in the system. Swiggy is one of our accounts located in India. They are very similar to a DoorDash for that region. And they came to us and they had a multi-model problem. They had built 6 different models. They had been implemented in different languages. They all had different types of response rates. And what they needed to do was build a consistent interface to provide inference into all those models while also providing a consistent layer of performance. They used Akka to create a singular interface across all those different models, and they have scaled that up to 4 million inferences per second at below 100 millisecond P99 latency, and this is billions of tokens on a per second basis. Another interesting example is a top 3 retailer that we're not allowed to disclose publicly. And they had a system where they needed to improve the time to resolution of errors that were coming in from a partner integration system. They were skeptical about agentic AI, but they also recognized that agentic AI could pattern match the error messages that they were receiving and offer an acceleration to their resolution. They had 5 billion messages coming into this system of a successful nature per year, but there were 500 errors that got into the dead message queue. And each one of these things needed to be manually remediated by a team of 10 operations professionals. They were business critical. And so in this case, they established an evaluation system. It was agentic AI, and they both analyzed all the successful messages so that they could pattern match against the error messages and propose recommended solutions on how you can go about fixing each one of those errors. They surface those error messages up to their operations team, and the operations team retained control over whether or not they were going to accept or reject the implementation. And at the end of the day, this little simple system, which had no exposure to customers, was allowing them to take their operations team from 10 people down to 6 people because of the reduction in the manual work they needed to do. Another one of our customers, Tubi, has an interesting ad serving system. And what they do is they make content recommendations both for users who are going to be watching content and those who are going to be receiving advertisements. And they receive information about users from over 12 different sources. These sources of information are coming from the user's activity. It's coming from associated advertising partner information about those users, and it's coming in on a real-time basis. And so they have a constant stream of user activity that is continuous. It doesn't end, and they have to aggregate that into a single understanding before they pass that on to models that can make the ultimate content recommendation. This system has to handle unpredictable loads because users come online, they disappear, and they have to handle all the users who are online at that point in time. They have 75 million monthly active users and over 12 streams that they have integrated. And finally, Llama, a startup that we had worked with, had to build a system that could work on over 30 million science papers and a petabyte of data in order to make recommendations to doctors and patients. It's a fascinating problem. Their theory is that there is so much innovation happening in the medical community that even doctors and specialists who have expertise in their area are unable to stay on top of all the therapies and treatments that are available to their patients for whatever, excuse me, stay in the call there, available to whatever issues or symptoms that their patients are experiencing. And so they wanted to build a system that could continuously parse 30 million science papers and then categorize that and have agentic AI agents acting as medical specialists to analyze the data and make recommendations back to patients and their doctors at the same time. They built 16 different agents with LLMs. They had to do fan out for collectors. They then had to have medical level categorization and reasoning. And then they had to train these agents on how to behave as certain types of specialists and then take all that information and summarize it down. In this particular case, they are breaking a complex pipeline down into multiple micro tasks, specializing the AI around a narrow task, and then putting that into a chain, ultimately delivering an outcome to that end user and the doctor. The nature of enterprise agentic AI is that now you have to build these AI systems that are tightly integrated with your IT systems without compromising on any of the operational realities that you had to deal with historically. This has been resilience, elasticity, and security, but with AI, it's also now safety and confidence. These are attributes that are incorporated into your embrace of AI, and so your SLA and the definition of what you have to strive towards increases. And with that, when you start thinking about how you're going to build fully autonomous agents that continuously improve, what you realize that you're going to be embracing is a world of not only distributed systems, but you are going to be working with goals. Agents are given goals, very strict goals that they have to work with. They're going to be given a set of guardrails that guide their behavior and define limits under which they're not allowed to exceed. And then elements of adaptation, both adapting to their environment or adapting to changes in knowledge that have come through whatever external systems that incorporate that. And so when you're doing agentic systems, you are dealing with reasoning, interaction, history, actions, knowledge, adaptation, inference, and all of these behaviors can actually be decomposed into basic distributed systems technologies that you can acquire today. And this is creating a new AI stack for Agentic, and that includes orchestration, which is similar to durable execution, memory, which needs to be both replicated and available in a durable manner, services that execute your tools and transactions, an event-driven fabric for integrating knowledge across your environment, and event-driven streaming so that you can, in real time, adapt to whatever changes your environment is giving to you, all while providing guardians that are continuously evaluating and ensuring that your agentic AI system never exceeds its boundaries. And this is what Akka is. We are a platform that makes it possible for you to design, build, and operate agentic AI systems where your services are fully autonomous, they are continuously improving, and they can meet the most stringent SLAs. Our customers reach millions of concurrent users. They can reach tens of millions in transactions per second, and they can do this with failover and disaster recovery in a multi-region setting. We have an SDK that is simple to learn and accessible to any developer, regardless of what their background is. And we can deliver this capability to you instantaneously. We'd like to make Agentic real for you. One of our special projects or offerings is that we can take your POC use case and we can turn it into a concept that is in a production environment that is ready for you to analyze and scale in 48 hours. We'd love to talk to you about what your AI use cases are. Please contact us by scanning the QR code in this slide. Or if you'd just like to learn a little bit more about what is Agentic AI and our approach to it, we have a number of resources available for you here. Thank you again, and we look forward to working with you.